Hi everyone, it's Mrs. Summer here to talk about lesson 902, angles and triangles. In this lesson, students will be able to classify a triangle by sides and by angles and use and understand the triangle sum theory, and you can also use and understand the exterior angles theorem. So classifying triangles by sides. So you've all learned about different types of triangles throughout elementary and middle school. We have a scalene triangle, an isosceles triangle, or an equilateral triangle. In a scalene triangle, there are no congruent sides, which means none of the sides in a scalene triangle are equal. In isosceles triangle, they have at least two congruent sides, which means that we have one side and this side and this side are equal to one another, but this side could be different. In an equilateral triangle, that means equal and all sides are equal. There are three congruent sides. And if we classify triangles by angles, the acute triangle means that you have an angle that is less than 90 degrees. So your angle is less than 90 degrees. A right triangle means you have one angle that is exactly 90 degrees. 90 degrees, right triangle. Obtuse angle means that this angle is going to be greater than 90 degrees. And an equilateral triangle means that they have three congruent angles. So this, and this angle are all equal to one another. So in this example, classifying a triangle in the coordinate plane. So classify the triangle OPQ by its sides. Then determine whether or not it is a right triangle. So we need to classify it by its sides, but we need to determine the length of its side. So in order to do that, we need to use the distance formula. Recall from our previous lesson, the distance formula is the square root of x2 minus x1 all squared plus the quantity of y2 minus y1 squared. So I'm going to first try to find the distance on this side. So the length between O and Q, so OQ length, is equal to the square root of 45. I'm not going to simplify that because the square root of 45 is not a whole number. I'm just going to leave it as the square root of 45 for this case. And then we're going to find the distance between P and Q. And when I use the distance formula to find the length of PQ, I get the length PQ is equal to the square root of 50, which means these are none of these have, the sides are the same, which means this is a scalene triangle. To determine if any of the angles are right angles, or whether it is a right triangle, we need to look at the slopes of the line P and Q and O and P. So we look at the slope of line PQ. We're going to have the slope of PQ is equal to y2, which is 2 minus 0 over -1 minus 0, which is equal to 2 over -1, which is -2. Then we're going to look at the slope of OP. I'm sorry, this is the slope of, let's look at this. I'm sorry, this is the slope of the line PO. Then now we're going to look at the slope of PQ, which is equal to 6. Oops, not 6. It is equal to 3 minus 2 over 6 minus -1, which is equal to 1 over 7. So these are not opposite reciprocals. So the only right triangles are perpendicular lines. So we need to determine if this is perpendicular to this or this is perpendicular to that line. You know that this is not a right triangle over here, but we can now look at OQ versus PO. Well, we already know the slope of PO is this. So now we need to find the slope of QO, which is equal to 3 minus 0 over 6 minus 0, which is equal to 1 over 2. So 1 over 2 is the opposite reciprocal. So if we write it over here, sorry, the messy, QO is perpendicular to the line PO, which means that this right here is your right angle. So finding the angle measures of triangles. When the sides of a polygon are extended, other angles are formed. The original angles are the interior angles, and the angle that forms linear pairs with the internal angles are the exterior angles. So these are your interior angles, and here, if we extended those lines, would be your exterior angles. So triangle sum theorem means that the sum of measures of the interior angles of a triangle are 180. So it just means that this angle plus this angle plus this angle is going to equal 180. The corollary to the triangle sum theorem is that acute angles of a right triangle are complementary. So that means that this angle and this angle are equal to each other. Or no, I'm sorry, they're not equal to, they're complementary because this is 90. So we already know that angle C is equal to 90. Well, then we have to know that angle A plus angle B has to equal up to 90 because the interior angles can only add up to 180. So in these questions, find the measure of angle 1, then classify the triangle by its angles. So right now, in number 11, we have angle 1 plus 78 plus 31 is equal to 180. So then we have 78 plus 31. So we have angle 1 plus 109 is equal to 180. 180 minus 109, angle 1 is equal to 71 degrees. So now you try number 12. And we're going to put number 13 here. I want you trying that one as well. So in number 12, angle 1 plus 40 plus 30 is equal to 180. Hold on. Whoops, there we go. Wrong button. 180. So angle 1 plus 70 is equal to 180. Angle 1 is equal to 110 degrees. And this is an obtuse triangle because this angle here, angle 1, is greater than 90 degrees. And then if we go back to question 11, question 11 is angle is an acute triangle, because angle 1 is less than 90 degrees. And now, if we look at question 13, we have 90 because of the right triangle, plus 2x plus x minus 6 is equal to 180. 2x plus x minus 6 is equal to 90. 3x minus 6 is equal to 90. 3x is equal to 96, so x is equal to 32. But that's not exactly what the question's asking. The question's asking find the measure of each acute angle. So this angle here is 2 times 32, which is 64. So 64 degrees here. And then we have 32 minus 6 here. And so 32 minus 6 is 26 degrees here. This triangle is a right triangle. Oops, does not look like a triangle. Right triangle because of the right angle. So this theorem, the external angle theorem, states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So what that means is that if we look here, the measure of angle 1 here, is equal to the angle A plus angle B, because they are not the ones that are right next to each other. So angle 1 is equal to here, this angle, plus this angle. So in this example, it wants us to find the measure of angle J, K, and M. So this angle right here. Now, the measure of this angle, according to the external angle theorem, is that 2x minus 5 is equal to x plus 70, because we're going to add these two angles together. When we do that, and now we're going to solve for x, we have x is equal to 75. Now, but that's not what the measure of this angle is. We need to do 2 times 75 minus 5, which is equal to 150 minus 5, 145 degrees. So that's that measure. So now you try this question. Find the measure of angle 1. So inside here now. So now you have to use two different properties. You have to use the exterior angle theorem as well as linear pairs. So to solve this problem, we first use the exterior angle theorem to solve for x. So we have 5x plus 10 right here is equal to this angle, 40, plus 3x, this angle, because they are the non-adjacent angles. So when we break it down, we solve for x is equal to 25. But that's not our answer. We need to now substitute that 25 back in. We find that 5 times 25 minus 10 is 115 degrees. Still not our answer, because we want to know what this angle, the inside angle, is. So we can solve it one of two ways. We can use the linear pairs to solve. So 180 minus 115. So 180, because remember this plus this equals 180. And when I solve it, I get 65. Or I could have substituted that x equals 25 in for here. Then that would be 75 plus 40 plus angle 1 is equal to 180. And I would still get 65 degrees.